Phase UART communication between STM32F103C8T6 and ESP32-WROM-32D. Both of these chips will be talking in UART form. For STM32F103C8T6 will be using STM32Cube IDE for programming, and for the ESP32-WROM-32D will be using the ESP-IDF for programming purpose. The STM32F103 will send the UART data to the ESP32-WROM-32D, so it receives it. So that's actually for the purpose. You can see from here, this is the ESP32-WROM-32D. ESP32-WROM-32D will be receiving a UART data from the STM32F103C8T6. So in the purpose, we have a CP2102N driver. Both is UART flashing to the chip. So one, as I mentioned just now, is STM32Cube IDE, and another one is ESP-IDF. So you can see from this pinout, from the A3 and A2, which is communication with the ESP32D WROM-32D. So there is where our UART communication occur, which is port A3 and A2 going to TX2 and RX2 for the ESP32-WROM-32D. ESP32-WROM-32D have 3 UART involved. So I believe STM32 also have 3 UART. So one as usual used for flashing, and this is also as well used for flashing. So the other TX2 and RX2 will be connect through UART, which is PA3 and PA2. For STM32, PA9 and PA10 will be using for flashing using the CP210N driver. So you can see I involved 2 CP210N driver here for UART flashing purpose. Then for ESP32D WROM-32D, we'll have they're using a TX and RX1 for flashing. So both can flashing using the Cube ID and ESP-IDF for our code editor, and flash with STM32 programmer and ESP-IDF respectively for the chip. So what you have here is the code itself. From STM32 Cube IDE, my code basically I will send a message is hi from STM32. Then this is my main function here. All is generated by the .ioc file, which you can enable the UART here, UART2, and also don't forget to enable the UART interrupt, for the global UART interrupt. Okay, so I'm going to load my STM32 Cube MX. You can see here, let me open up loading the IOC file. TX and UART2 RX, which on the PA2 and PA3. On the connectivity, I believe on UART2 enable here is synchronous, and UART2 global interrupt, I enable it. So this then I choose project manager, I choose STM32 Cube IDE as my toolchain, then I just generate my code. This will bring me up to my IDE here. So this is my STM32 Cube IDE. So what I do is then I use STM32 Cube programmer to just flash it to the STM32 chip, which is the blue pill chip. Then for my ESP-IDF side, I also flash it. So you can see this is what I'm getting actually from the receive part. Receive high from STM32 from the UART RX, you can see from here. So you can see this is the code involved, which is UART num2. Baud rate should be matched as the one on the STM32, which is 115200, and our UART TX pin and RX pin will be 16 and 17. Buffer size we set it 1024. So this is the UART task, the data which will be receiving on the ESP32 WROM-32D here. Then this is our config, UART config, and we can create a task here to receive it. So child point data. So this is what we're receiving here. I from STM32. Okay, that's it guys. Actually I want to show for this purpose. Why this purpose? We can enable the Wi-Fi connectivity actually. What we have here is the STM32 chip will sending the data to the ESP32 WROM-32D. Then from the ESP32 WROM-32D we can send it to the Wi-Fi. That's how we can make it for later. Wi-Fi, then we send our web page. You can send all the data from there. So because of this, actually ESP32W, what I realized is that they have a very poor on ADC control. STM32 have better on ADC control. That's why we take the data ADC STM32 STM32, then from STM32 send data to ESP32-WROM-32D, so the ADC value is more accurate. So from there we can display to our web page or our sort of any data on the web page. So yeah, that's it guys. For this video, I'm just going to show you how you can interface from different MCU and how we can use its own capabilities for each purpose. Thanks guys for watching. See you in the next video. Bye.